These examples are going to review some of the concepts in Chapter 2, including the theorems and definitions and angle pair relationships. Let's start with conditional statements. Rewrite as a conditional statement, all sharks have a boneless skeleton, so we need an if-then statement. All sharks have a boneless skeleton. Answer choice A, if a fish is a shark, then it has a boneless skeleton. Okay, which is a counterexample? If x is greater than 5, then 2x is less than 15. Well, if we consider our answer choices, A is not a counterexample because it doesn't satisfy the hypothesis if x is greater than 5. So let's start with x equals 6. The problem with x equals 6 is 2 times 6 is 12. 12 is less than 15, so that's not a counterexample. 7 for x, 14 is still less than 15, so that's not a counterexample. We need a value for x that satisfies the hypothesis, but that makes the conclusion not a true statement. So x equals 8, 16 is not greater than 15. So answer choice D is our answer. Okay, write the converse. If two segments are congruent, then they have the same length. If two segments are congruent, so two segments are congruent, this is our hypothesis, then they have the same length, is our conclusion. The converse switches the position of these two and makes the conclusion the hypothesis and the hypothesis the conclusion. So which of our answer choices is that? Answer choice C, if two segments have the same length, that's our new hypothesis. The conclusion is that the segments are congruent. Okay, which of the following are equivalent forms of conditional statements? A conditional statement is equivalent to its contrapositive. So choice A is out, choice C is out, the contrapositive is equivalent to the conditional, and choice D is out because the conditional is equivalent to contrapositive, not the inverse. So that leaves us with answer choice B is the only one that's correct. And converses and inverses are equivalent statements. Here are two statements. Statement A is the Ravens win. Statement B is not the Ravens bye week. And we want to write the biconditional statement. A implies B and B implies A. Keep in mind that this biconditional is equivalent to saying that A implies B, but that also B implies A. These two statements are both true in a biconditional, so we want if the Ravens win, then it's not the Ravens bye week. The Ravens will win if and only if it is not their bye week. So that's the biconditional. But also, we also have to keep in mind that this could also be written as B if and only if A also. So there's another answer choice, and that is answer choice D. It is not the Ravens bye week if and only if they win. So both C and D are correct versions of our two statements as a biconditional. Write the biconditional statement below as two conditional statements. So this is taking the previous example, similar to the previous example. You go to PVHS if and only if you are cool. So here's, you go to PVHS, that's like statement A. if and only if you are cool is statement B. So we want to write this as two conditional statements. So if A, so if you go to PVHS, then B, then you are cool. So that's if A, then B. We also want if B, then A. So if you are cool, then you go to PVHS. So the first statement here implies that all PVHS students are cool. If you go to PVHS, then you're cool. Our second statement implies that all cool people go to PVHS. And therefore, anyone who goes to PVHS is cool, and all cool people are at PVHS. Okay, which of the following is a statement of the law of syllogism? The law of syllogism, if you remember correctly, is similar to the transitive property, but for conditional statements. So if we look at our list of options, A, B, C, D, A and B have to do with conditional statements. C and D are statements of equality or congruence, so that doesn't have to do with the law of syllogism. It's got to be either A or B. And A is the sort of transitive property where A, if A then B, and if B then C, then our conclusion is if A then C. That's going to be the answer. Answer choice B is the law of detachment. Okay, now what property allows us to take the equation 2x minus 3 equals 10 and add the 3 to both sides? You can see we've added 3 to get 2x by itself. 10 plus 3 is 13. So answer A, the addition property of equality, is what was exampled there. Here's another situation, AB equals CD, CD equals EF. Our conclusion then is AB equals EF. We've seen this in many examples. That's the transitive property. Here we have an angle, measurement of angle A equals measurement of angle B. We can then flip the order of the equality and say that the measurement of angle B equals the measurement of angle A. The flipping of the order is the symmetric property. Okay, if AB plus BC equals 24 and AB equals 10, then the 10 can be put into the equation, so 10 plus BC equals 24, example of the substitution property. Okay, what are the reasons for each step when solving negative 2 equals 3x minus 7 to get x equals 5/3? Well, we're trying to solve for x, so we've got to add 7 to both sides, so we're going to start with addition. So answer choice A or B then. We then still have to get rid of the 3, which is being multiplied times x, so we're going to divide both sides by 3 and use the division property of equality. So we're looking at answer choice B. Now what's the symmetric part of that? Well, if we add and then divide, we're going to end up with 5/3 equals x. But in order to get our statement into the form x equals 5/3, we need one more step applying the symmetric property to get the x on the left side and the 5/3 on the right side. If you know that angle 1 and angle 2 are complements, angle 2 and 3 are complements, we want to know what we can conclude about angles 1 and 3. Well, the complements of congruent. If two angles are complements of the same angle, then they must be congruent, angles 1 and 3. Okay, which statement is not true given the diagram below? Let's see, if we go through these statements one at a time, angle 3 is congruent to angle 4. These appear to maybe be vertical angles, but they're actually not vertical angles. So this may not be true. We'll keep A as a possibility. Measurement of angle 7, which we know to be a right angle, plus the measurement of angle 2, plus the measurement of angle 4 equals 180 degrees. You can see here's angle 7, angle 2, and angle 4. They're actually a linear triple. They form a straight angle there, so we know that that's true. So answer choice B is definitely true. Measurement of angle 3 plus the measurement of angle 5 equals the measurement of angle 4. Well, there we can see measurement of angle 3 plus the measurement of angle 5, that actually does form that angle addition there is vertical with angle 4. So those are congruent angles. Their measurements actually are equal. So C is a true statement. And angle 6 is congruent to angle 7. Again, we've got vertical angles, angle 6 and angle 7. So that's a true statement. That must mean answer choice A, which we originally suspected to be not true, is the statement that's not true. Okay, one last step here. Given that the measurement of angle 2 is 25 degrees and the measurement of angle 5 is 30 degrees, find all the other angle measurements. So angle 2 is 25 degrees, angle 5 is 30 degrees. Find all angle measurements. So we need, let's start with angle 1. Angle 1 is vertical with angle 2, so angle 1 must be 25 degrees also, okay, because they're vertical. We know the measurement of angle 2. Let's see if we can figure out the measurement of angle 3. Well, if angle 1 is 25 degrees and angle 5 is 30 degrees, I know that the measurement of angle 1 plus the measurement of angle 3 plus the measurement of angle 5 is equal to 90, because those three angles form a right angle. And so 25 plus the measurement of angle 3 plus 30 is going to equal 90 degrees. So the measurement of angle 3 plus 55 is 90. Our final answer there is 35. So 35 degrees for measurement of angle 3. So we have 1, we have 2, we have 3. We need the measurement of angle 4. Up above we saw this to be a true statement. Measurement of angle 4 is 3 and 5 added together. We just solve for the measurement of 3. We know 5 is 30 degrees. So angle 4 is 65 degrees. So we have angle 1, 2, 3, 4, 5. We need the measurement of angle 6. We know that that's a right angle, 90 degrees, because it's vertical with angle 7. Measurement of angle 7 is 90 degrees. It's a right angle. And we've got them all.